So, hello guys, welcome to my YouTube channel Data Stories. In the previous lecture, we have seen the practical part of linear regression. In today's lecture, we will see the problem of the linear regression, that is overfitting. That means we get good result on trained data and bad result on test data. So, how to overcome this problem, we will see in this video. Okay, if you haven't watched my previous lecture, I will suggest you to go through it. And also the note I am providing that are the most important notes that it will help you in your interview. Okay, so let's start with our lecture. So one major problem of linear regression we saw that is overfitting. Okay, that is low bias and high variance. Good result on trained data and bad result on test data, right? So to overcome this problem, we are using two regularization technique. That the first one is Ridge and second one is Lassos. Okay, so I am giving you the homework task. That is, I will provide you this trained data set. You have to build a linear regression model on that by using the same step that I have taught you in my previous lecture. You have to follow the same step, nothing else. Okay, the difference is that you have to do the evaluation. I have taught you the evaluation parameter, right? I have said you to test it only on test data, right? Here you have to test it on both the data, that is test and train. And you will see that it is giving good result on trained data and bad result on test data. I will show you my Jupyter notebook file and then we will see how to apply Ridge and Lassos to it. Okay, so this is my Jupyter notebook file. Here you can see that I have first imported the necessary libraries, then I have read the data set, then I have used the head function to see the first file column, right? Here you can see that we have the y as our target variable, right? And this ID is a unique column, so we have to delete it. So in the later step, we have deleted it. Here we have used a dot shape, a dot size. We have seen null values. There are no null values present in this data set. We have deleted this ID column as it was unique. Okay. So the next step was like using label encoder to convert the all object columns into numerical, right? Okay. The next step was sampling. This is sampling step. Um, so we have divided our data like like our first column was test train variable, right? So we have given the first column as train y, okay, and the rest of the column as train x. As we have deleted the ID column, so our first column becomes. I'll show you here. We have deleted this ID column, so our first column is target, and rest are our x variables. Okay. So later that we have built the linear regression. We have tested the evaluation parameter. You can see that we are getting R square on train data as 58%, right? I adjusted R square as 53%, L coefficient. These are the P1, B2 values. I have taught you the linear regression equation. Hope you remember it. That was y equal to b naught plus b1 x1 plus b2 x2. Okay, so this is b1, b2, that kind of values. L coefficient. Okay, so the next step we have performed is like L intercept. B naught was the intercept, that equation I have just said. Okay, so again we have done the prediction on train and test. Okay, so we have find the error on both train and test. Then MSC on MSC test. Okay, so what was MSC? MSC was lower than SC, better is the model, right? So on test we are getting 7.9187 MSE, right? And on train data we are getting 66.26% MSE. Now you will think that, sir, you are wrong. MSE is smaller in this test case. And you have said that in linear regression, sometimes the problem occurs that it will give good result on train and bad result on test. But here is lower the MSE, better is the model. So MSE test is doing the better model. But look at last. Here is E raised to plus 90. That is too long. So this is giving bad accurate, and this is giving good. Hope you understand. And the next step we have then we have find the RMSE. Okay, the RMSE also perform can be judged on the same. Lower the RMSE, better is the model. So here we are getting such a high RMSE, so it is bad, and then we are getting low. And the same other I have performed on other evaluation parameter that you have to do it by yourself. I will recommend you to please don't watch this video till here. Do try it by yourself. If you get stuck in any step, then you can refer this. Okay. So now, as you can see that we are facing the problem of overfitting. Okay. So to overcome this problem, we are going to use the regularization techniques that are Ridge and Lassos. Okay. From so first Ridge. The syntax is same from a scalar dot linear import reg. Okay, I will store it in variable r reg. Okay, saying I have to use the pick function on train a train x comma a train y. I will run it. I have to wait for some time. Okay, now it is getting run. Okay, I have found an error. Okay, okay. On the scalar linear model. It is getting run as you can see. So now we will check the MSC RMSC. I will go above and copy this MSC, right? I have to just prove that we can avoid the problem of overfitting by using Ridge. So we write it here. MSC test. Just a second. Oh, I haven't predicted the values. Pred equal to r dot predict a test x comma a test y. Okay, so the same step we have to perform here, like to find the error and all. So I will just copy paste from above. Okay, so first we will find the R square, right? R square, I have copied it from here. I will paste it here. The main difference is here is not L. Here I have used R. So this is on train. You may see that we are getting 58% accuracy on train, right? So the same we will test it on test. So we are getting 57.77% accuracy here. That is greater from this. Okay, I haven't performed on test data, so I will create a new line. I will show you L dot score. I want test x comma e test y square. I will restart it. I will run it from first. Then you will understand. Okay. See, we are getting minus 4.85 accuracy here. It is too bad. And when I have used here Ridge, you can see that our score value has increased in test. So the same evaluation parameter you have to use, and you might try the out other evaluation parameter here. Okay, homework, try out other evaluation parameters and check for both train and test. Okay, so now we will see the lassos. I will only build a model, the list evaluating the evaluation parameter you have to do. It's your homework task. I have shown you an example, the same you have to follow down. If you have any doubt, you can ask me in the comment section. So I will just go up. I will copy this, right? And I will paste it here. Input lasso. Here is t equal to lasso t dot with equal to lasso. Okay. So you can here you can see that the lassos model have built. Now the same evaluation parameter you have to use here, and whichever model perform the best, that you have to use in your final application. So if lassos is doing better, then you will use only lassos. If linear is doing better, then you will use linear. Okay, so you are getting my point. I hope you are getting the concept. If you have any doubt, you may ask me in the comment section. That's all with this video, and I hope that you will build this model. And if you have any doubt, you may ask me in the comment section. And I will suggest you to keep practicing, as practice will help you to achieve your goal. So if you like my video, please like it and subscribe it, and it will motivate me a lot. So thank you for watching my video, and I will see you next time.